Thanks for dropping by. Today we're going to review units and dimensions. Units and dimensions, they tend to be used interchangeably, but personally, I prefer to use the word units because the word units tells us how it's being measured. Dimensions tell us all the different parts that were included in the measurement. So for example, we're going to look at 13 Newton meters. The units, Newton meters, or the letters after the numbers, tells me what it was measured in. It was measured in Newton meters. So this is probably a work or torque. The dimensions, the Newton meters, tell me that force and distance is important when we're talking about torque. Since newtons is a force and meters is a distance. So in summary, units tell how and what was measured, whether it be force or torque or acceleration. Dimensions tell what is important to that measurement. So in units and dimensions, we have what is called like terms. For example, if you have 7 dogs and 3 cats, how many dogs do you have? You only have 7 dogs, not 10, because you can only put things that are exactly the same together. Similarly, let's look at another example. If you have 2 cubic feet and 3 square feet of soil, the amount of soil that you have still has to be 2 cubic feet and 3 square feet. You can't say the total is 5. You can't put the two of them together because they are different quantities, different units. A unit can have several different parts to it. And as noted before, the unit that we're going to use is torque, which is in Newton meters. And as noted before, newtons is force and meters is distance. So those two different parts make up torque. Let's go one step further and look at the newton, which is force. A newton is described as 1 kilogram per meter squared. This tells us that mass is important and acceleration is important, which makes sense. If you have a feather and a stone exactly the same size, you drop the feather on your hand, it's not going to hurt as much as the stone. And acceleration makes sense too. Stopping a slow moving ball is a lot easier than stopping a fast moving ball. Now let's look at an example. And make sure that you watch the units. A ball has a mass of 0.3 kilograms and the acceleration of the ball is 100 meters per second squared. What is the force of the ball? Remember that force is measured in newtons. So oftentimes you're going to be given the formula for force, which is mass times acceleration. And now we just plug in our numbers. Notice when I plugged in the numbers, I kept the units for a few different reasons. The units act as a reminder that if everything isn't in its base unit, then I can change it. The units also act as a reminder of the importance of like terms. It has to be in the proper spot. Also, when calculating, remember there is no magic in life. So all the units, whether they be newtons, watts, joules, or omegas, must come from somewhere. And this shows that all the pieces that are in the unit. So when we calculate it, it ends up being 30 kilogram meters per second squared. All the units are there, nothing just magically disappeared. And as a reminder, that force is measured in newtons, and 1 newton is the same thing as a kilogram meter per second squared. So we can write down that it would be 30 newtons. So in summary, units tell us how it's measured. Dimensions tell us all the different parts that are important. Units and dimensions tend to be used interchangeably, but I prefer to use the word units.